Good morning everyone. I am Dr. N.J. Vignesh, working as an assistant professor in the Department of Mechanical Engineering, SRM Madurai College for Engineering and Technology. Now let us see a video on engineering graphics under the title Cycloid. What is meant by a cycloid? A cycloid is nothing but it is a curve which is generated by a point on the circumference of the circle as the circle rolls along a straight line without slipping. For example, if you take a small tire, okay, inside this tire, if I mark a point at the lower end, let us assume this point as capital P, and if this tire is allowed to move for one complete revolution, that is for 360 degree, and if I trace the position of this point along the rolling tire, then after joining all these points I will be able to generate a curve which is nothing but a cycloid. So this is said to be called as the definition of cycloid. So once again let us see what is cycloid. A cycloid is a curve which is generated by a point on the circumference of the circle as the circle rolls along a straight line without slipping. So during this process of movement it should not slip and it should move in a straight line. That is the condition which is necessary for generating this cycloidal curve. Okay. So here there are some names which are given. First name is the moving circle is called as generating circle. So this circle is said to be called as generating circle, and the straight line onto which it is moving for 360 degree is said to be called as directing line or base line. Okay, the line onto which the circle moves for 360 degree is said to be called as directing line or base line. The point on the generating circle which generates the curve is called as generating point. So this point P, which is initially available here, is said to be called as the generating point. Moving on to the next slide. So you can see from this animation very clearly how this cycloidal curve is generated. Initially, if you identify that this point P is located at the bottom of the circle, but as the circle revolves for 360 degree complete revolution, you can see that this point comes from the lower end and once again reaches the lower end after moving along the circle. So while tracing this moving point, we will be able to generate a curve. Okay, that is nothing but cycloid. So we can see it very clearly from this animation. Now how to draw a cycloid? So the geometrical technique for drawing the cycloid is shown below. So initially there will be a circle. So the circle is divided into 12 equal divisions. For example, in the problem, the diameter of the circle will be given. Based upon the diameter, we need to draw the circle. Then after drawing the circle to the necessary dimensions or necessary diameter, it is the necessity for us to divide the circle into 12 equal divisions. We can also divide the same circle into 8 equal divisions, but if we divide it into 12 equal divisions, the curve which is drawn will be very smooth. Okay, we will be able to get continuous points at a very nearer distance. If the points are very located at a larger distance, then the smoothness of the curve obtained will be very poor. Okay, that is the reason why we are moving for 12 points. So here you can see that the circle is divided into 12 equal divisions by using a protractor. Then after dividing this, we need to draw the baseline. So baseline is nothing but it is a generating line. So the dimension of this baseline will be equal to the circumference of this circle. So if we open the circle, we will be able to find that the dimension of the baseline and your circle circumference will be equal. Therefore, this particular baseline or generating line will be equal to pi into d, which is nothing but the circumference of the circle. For example, if the diameter of the circle is 50 mm, then the length of the baseline will be equal to pi into 50. Okay. After drawing this baseline in turn will also be divided into 12 equal divisions, which is equal to the sector of the circular divisions. So already we have divided the circle into 12 equal divisions. Now what I am going to do, I am going to take a divider, and using the divider I am going to measure the dimension of a particular sector, okay, or an arc length. For example, the distance in between this point 6 and 7, I am going to measure this gap. So this gap will be constant for all the 12 points. Using this gap, I am going to divide the baseline into 12 equal divisions. So if we do so, the baseline will be also be divided into 12 equal divisions as we have done it for the circle. Okay, so that is the purpose of using the divider. So using the divider, measure the particular sector, any one sector, not only the distance between 5 and 6 or 6 and 7. You can use either the point in between 1 to 2. Okay, so it will be equal. So using this sector, you divide the baseline into 12 divisions. So this is the second stage in drawing or developing this cycloidal curve. Then after doing so, I am going to draw parallel lines to this baseline from all the points which are available on the circle. For example, I am going to draw one parallel line connecting point number 12 and 1, and I am going to extend it until this point 12. Okay, you can see here. So from this point 12 and connecting 1, I am extending one parallel line. Similarly, from this point 11 to this point 2, I am extending one parallel line up to this point 12 on the baseline. Similarly, from point 9 joining point 4, I am extending a parallel line. Similarly, from point 8 to point 5, I am extending a parallel line. So from point 7 to point 6, I am extending a parallel line, and finally from the topmost point. So ensure that all these parallel lines are straight and parallel to the baseline. Okay, if they are not parallel, then it will be very difficult for us to develop the cycloidal curve, because it will generate some error. So it is very important to draw all these lines parallel to the baseline. The next step is to draw points exactly parallel to the baseline points which we have divided earlier. Earlier we have divided the baseline into 12 equal divisions by using the sector or dimensions of the sector by using a divider. Now, placing our scale vertically and perpendicular to the baseline, I am going to mark 12 points onto the central line, which is originating from this central point. Let us take this point as O. If this central point is O, on the central line I am going to mark the same 12 divisions as parallel to the baseline 12 points. Okay, so this is point, we can assume this point is C1, C2, C3, C4, C5, C6, etc. up to C12. So these points are necessary for us to develop or identify the generating points. Okay, let us see it in the next slide. Now what I am going to do, I am going to take my compass. Taking my compass and measuring a value equal to half the value of the diameter, which is equal to 25 mm. We initially know that the diameter of the circle is equal to 50 mm. Now I am going to take a dimension equal to 25 mm and measuring that value, and initially I am going to place this compass pointer at point C1. Please ensure I am going to measure 25 mm and I am going to place this compass pointer at position C1, and with 25 mm as radius and C1 as center, I am going to cut one arc on the first parallel line from the baseline. Okay, so this is my point 1. Okay, this is my point 1 for the cycloidal curve. Then using the same dimension 25 mm and moving to point C2, I am going to cut another point on the second horizontal line from the baseline. Then moving to point C3, I am going to cut another point on the central line. Then moving to point 4, I am going to cut another point on the fourth line from the baseline. Then moving to point 5, I am going to cut another point on the fifth line from the baseline. And moving to point C6, I am going to cut another arc which will be exactly touching the topmost line. Okay, here we will not be able to get any cutting point, but it will be exactly touching point number 6. Okay, we can see it in the next slide. In this way, moving on to point C7, I am going to repeat it in the reverse manner. By using 25 mm as radius and position as C7, I am going to cut an arc on the line, fifth line from the baseline on the right hand side. Then moving to point C8, I am going to cut another point on the fourth line from the baseline, which is equal to the 8th point. Then moving to C9, I am going to cut another point on the central line. Moving to 10, I am going to cut another point on the second line. Moving to 11, I am going to cut another point on the first baseline, and moving to 12, here I will be once again exactly able to touch the baseline, which is the 12th point. Okay, So you can see that these are all the 12 points which we have obtained. Okay. So this is point number 1, point number 2, 3, 4, 5, 6. So as I said before, the sixth point will be exactly touching at the topmost line. And 7, 8, 9, 10, 11 and finally 12 also will be touching exactly at the baseline. Now using a smooth pencil, we need to join this curve either by using freehand, or you can also use any French curve for connecting all these points. So finally you will be able to generate a curve which is nothing but a cycloid. So this is how your cycloid is generated. So you can see that initially this point is at the base, but as this circle revolutes for one complete 360-degree revolution, we will be able to generate these points which will result in generation of a cycloidal curve. So this is how your cycloid is generated. Now let us see a small problem. As we have seen, we are going to assume the same diameter 50 mm and we are going to also draw a tangent and normal to this particular curve at a point 35 mm above the baseline. So this is the question which is given. Now let us see this problem. So all those points which we have described earlier will be explained in a detailed manner. Now let us directly move on to the diagram. So what we are going to do, initially I am going to draw one circle for a diameter equal to 50 mm and I am marking the dimension as pi 50. Okay. So here the central point of the circle is marked as C, and after drawing the circle using my protractor I am going to divide the circle into 12 equal divisions. I am giving the base point as P and it is also given the number 12. Okay. So this is the lowermost point 12 and here it is 1, 2, 3, 4, 5, 6 etc. and until 12. So the base point is given as P. Okay. Now what I am going to do, I am going to draw one generating line or baseline for a dimension which is equal to pi into d. So what is pi into d? Pi into d here is equal to 157 mm. So d indicates the diameter of the circle which is equal to 50 mm. So 50 into pi we will be getting 157 mm. So I have drawn one baseline for 157 mm and now it is time for me to divide this baseline also into 12 equal divisions. So what we need to do, we need to take our divider and we need to measure the dimension of any one sector using the divider, and we need to divide this baseline into 12 equal divisions. Okay. So each division is marked as 1 dash, 2 dash, 3 dash etc. until 12 dash. Okay. And I am also giving the last point as Q. Okay. That is our your choice. You can give either Q or you can omit it. Okay. That is not compulsory. Now the next step is we need to draw horizontal lines. Okay. So we need to draw horizontal parallel lines to the baseline starting from point 11, 1 and extending it until 157 mm. Then from 10, 2 and extending it until this edge line. 9, 3 and extend it here. 8, 4 and extend it here. 7, 5 and extend it here. 6 extend it here. Okay. So all these lines should be stopping exactly at point 12 dash. Okay. It should not go beyond that. If it is going beyond, you need to erase it. So this is the third step. The next one, we need to mark the central points. So in order to mark the center points, either you can use your divider or you can also use your scale and place it perpendicular to the baseline and at each point. Okay. For example, if you are using your scale, you place it at 1 dash perpendicular to the baseline and mark C1 at the central line. Then moving to 2 dash, you mark C2. Moving to 3 dash, you mark C3. Moving to 4 dash, you mark C4, etc. etc. Okay, like this you will be able to generate all the central points. Now next step is we need to take our divider and placing it on C1 and taking a dimension equal to half of the diameter, which is nothing but 25 mm, and with C1 as center I am going to cut one arc on 11, 1 line. So that is my point P1. Then moving to C2, cut with the same dimension 25 mm point P2. And moving to C3, here I am getting P3. And moving to C4, cut one arc on the fourth line, which is P4. And moving to C5, cut one arc on the fifth line, which is P5. Moving to C6, I am cutting one arc on the topmost line, which is P6. Moving to C7, cut one arc on the right hand side, P7. moving to C8, cut on arc on the fourth line, which is P8, moving to C9, cut on arc on the central line P9, moving to C10, cut on arc on the second line P10, moving to C11, cut on arc on the first line P11, and finally moving to D, I will be able to identify that the point is exactly touching 12 dash or Q. Okay, now using our pencil or French curve, I am able to draw a smooth cycloidal curve. So this is how you will be able to generate a cycloidal curve. Now the next step here, what we need to do is we need to draw one tangent and normal. So they have asked us to draw a tangent and normal at a distance of 35 mm above the baseline PQ. Okay, so what I am going to do, I am going to take my scale and place it in such a way that the zero of my scale is initially at the base, and as I move the scale from the right hand side, I will be able to measure 35 mm exactly on the curve. Okay, or you can also use your roll and draw scale. Okay, roll and draw scale or common scale. So if you are able to use your common scale, move it very smoothly without compromising on the perpendicularity from the base, and if the 0 is at the base and here it should be 35 mm. So mark that point as capital M. So while we are measuring this distance, it should be equal to 35 mm. Now from this point M and taking my compass, measuring a value equal to 25 mm, I need to cut one arc on the central line. Okay, so first of all I need to mark one point M at a distance of 35 mm above the baseline, and next step is take your compass, measure a distance of 25 mm and cut one arc on the central line. So that point is indicated as X. Okay, and the radius is 25 mm. From point X you draw one perpendicular line to the baseline. From point X you draw one perpendicular line to the baseline. So that point is indicated as N. Now from N you join this line M and extend it for some convenient distance, and it is indicated as N dash. Now N dash indicates the normal. Now N dash indicates the normal. Okay, once again I repeat, initially mark a point M at a distance of 35 mm above the base, and from M you take your compass and measure a distance of 25 mm and cut one arc on the central line, which is indicated as X. From X you draw one perpendicular line to the baseline and it is marked as N. Now connect N and M and extend it for some convenient distance and mark it as N dash. Now N dash indicates the normal to this cycloidal curve. Now take your protector and place it on M and measure 90 degree or 180 degree on either ends. Okay, for example, if you are placing your protector like this, okay, that is N dash indicates 0 to 90 degree, then mark 2 points on 0 and 180 degree on either ends. Okay, sorry, this is the central point and this is the 90 degree, then mark one point on right hand side as 0 and left hand side as 180 degree. Now join these 2 points in such a way that it exactly touches only at point M. So this T dash, it is indicated as T dash. This T dash is nothing but the tangent to the cycloidal curve. Okay, so normal and tangent are exactly perpendicular to each other. Okay, that is the concept. So here place your protector at point M by placing it 90 degree to N dash, then mark a point on 0 and mark another point on 180 degree, and now join these 2 points and indicate it as T dash, then you will be getting the tangent to the cycloidal curve. So this is how you will be able to draw the tangent and normal. I hope you have enjoyed this video. So this is about a video on cycloid. Thank you very much.